All right, welcome to Logic 101B queries. So what we're going to talk about today is SQL and what SQL is and what it's for, and a little bit about how to use it. And we're going to cover this from the perspective of someone who is trying to add the most possible value to a project that they're working on, and we're not going to necessarily get into the details about why things are the way they are or how they work under the covers. We're just focused on being a productive user of this tech. So SQL is like this really kind of old language that was put together, I think in the 70s maybe. It stands for, I believe, Standard Query Language. It is a language of queries. So by query, it's like a question, right? It's the question you ask of some server, right? You'll have a database server, and that database server might be MySQL, it might be Postgres, it might be Microsoft SQL Server, or sometimes known as MS SQL, it might be a SQLite server, it might be an Oracle database, it might be a DB2 IBM database, or a bazillion other possibilities. These five are some of the most common that you'll see. Standard query language was basically created to solve the problem of, hey, there's some data that I need to structure for my organization, and then I need to be able to retrieve it. So let's talk about how to run a SQL query. The easiest way for us to play around with SQL is to open up a tool like SQL Pro if you're on a Mac, or any kind of SQL workbenchy sort of thing like this that lets you go in and run stuff. You may be familiar with something called Php Myadmin. You may have seen that before. That was kind of the classic PHP and MySQL approach. And that was something that ran in a browser. It doesn't really matter how you get there. It just matters that you can get in and run queries. Looks like a test here. So I'm using a random database called test4271 that I just found on my computer. It looks like it has one table called pet. So part of SQL is that it's a query language, but it also kind of wraps up this idea of what the thing you're querying looks like. So if you're going to ask a question, the thing that's going to answer your question you have to have some shared assumptions, right? Like if I ask you guys a question in English, then I'm expecting that you also know English, and you're going to be able to respond in English, right? And so that's where it's a little bit different. SQL doesn't respond in SQL ever. It responds in different ways. The way that it responds, so for example, let's say that I was to ask, how many pets are there? Seven. So it tells me that there's 7 pets. Okay, so this is a SQL query. I'll explain more about what that is in a second. But the thing to understand is that we send SQL, this is SQL, and then we get other stuff back from the database. We get results. A lot of times these results are in the format of a table. Sometimes they're not. So if I want to do insert into pet, and I always forget how insert queries work, so I'm just going to Google it, because normally I don't have to type a whole lot of SQL. Like normally, see, Waterline, which is a component of the Sails framework, does all this for us. And this is W3 Schools, which isn't the best place to get your information, but for our purposes here, it's fine. Insert into table name, and then we list which columns, and then we say what our values are, and we say which values. So for example, insert into customers, customer name, contact name, address, city, postal code, country. Cardinal is the customer name. Tom B. Erickson is the contact name. Skagen 21 is the address. Stavanger is the city. 4006 is postal code, and the country is Norway. So for example, let's say that I was to ask, how many pets are there? 7. But the thing to understand is that we send SQL, this is SQL, and then we get other stuff back from the database. We get results. A lot of times these results are in the format of a table. Sometimes they're not. So if I want to do insert into pet, I don't actually know what our pet has, right? So I'm going to look at the structure of the table. And these are the different columns. You can see it's got created at, updated at, ID, name, and species label. Now, normally we do our fields as camel case. So you would see like species label with a capital L. Okay, so let's insert into pet where a name. Let's just give it a name for now. So name, values. Okay, let's use your cat. Gray winner. I don't know why I keep saying Gandalf. All right, we'll use the British spelling of the word gray. All right, so you see there was like no results, right? But down here it says no errors, 1 row affected, taking 7.5 milliseconds. And then back over here, I think I got to refresh. You can see there's gray wind. And that's what insert does. It's like create.
Insert doesn't like replace. Insert only creates.
That's right. There's something called update that you use to do an update. But I just wanted to cover first, here we didn't get any results. When you hear the word SQL, this is the SQL part, the part that you send. So it's like if I asked you a question in English and then you like brought me a pet or a few pets or nothing, you just nodded your head. That's what it did here. This is it nodding its head at us. So here you can see our created at column is null and updated at is null. Every database has different rules about how they handle this kind of stuff. There's a way to set a default like built into the database itself. We don't ever really use that in the Sails framework. You can, right? And some people do and sometimes there's even like reasons to do it if you're trying to optimize your platform, right? But for most things, that's not really ever the bottleneck. So what instead that we do by default in Sails is if you don't specify a created at, well, in Sails it'll automatically set the created at to be the current time. Same thing for updated at. But let's just say that this is just any other number field. It's going to come in as 0. And the reason for this is because then later on in your code, if you're trying to do math, you don't suddenly find yourself trying to do math with null, which won't work because 1 plus null means that everything freaks out and your stuff has an error, right? Okay, and last but not least, same thing here. This is a string, like dog, cat, lion, tiger, snail. Null doesn't work really good as a string, right? Like when I'm doing something like hello plus null, I get hello null, and that's confusing. I think a better behavior would be something like that, right? The other reason for this is, let's say I had a variable and it had a string in it, and I could do, let's say, gray wind, for example. I could do x.length and it would tell me how many letters are there, right? Or I could do like x dot any of this, right? I could split on spaces, which there's no spaces in gray wind, but if I do x equals gray wind is a cat, then now I get gray wind is a cat. And all that works great, even if x is empty string. Like, well, it doesn't work great, but it still is functional, right? Whereas if I say x equals null, and then I try to do that, we get an error, which is not what ideal, right? So that's why we do it the way we do it in Sails, is really just to protect you. And so in Sails, if you're using the ORM, you'll see something like this instead. So the question is there any, if that any number will be 0 by default and that any string will be empty string by default? And the answer is yes. And any Boolean will be false by default. Okay. We call those the base values. So that's not really SQL specific, but that's just important to understand SQL in the context of Sails. You'll generally, if you're using a database that is part of a Sails application, you can generally rely on this. But you'll also keep in mind, you're going to be writing raw SQL queries sometimes outside of the context of Sails. And that's what we're going to talk about for the rest of today. All right, so there are arguably 3 categories of queries. One is DQL query, another is a DML query, and another is a DDL query. This isn't super important except as a way to categorize these things in your head, and I find it helpful for me. So a DQL query, that stands for Data Query Language. Now technically, all of the things you send to SQL database are queries, right? So you could kind of say that everything is part of a data query language. The difference is we kind of use that as a catch-all to mainly talk about select queries. Okay, so like any other kind of query, which is generally select queries. So when you're looking up data. Now DML, that stands for Data Manipulation Language. Adding, updating, creating, stuff like that. Manipulating data. manipulating, and I'm just gonna cut that out and say records, right? We're manipulating these records, maybe more than one at the same time. Last but not least, and we're not gonna go into this very much right now, I just want you to understand there's another category of queries out there that you may occasionally see in your life, which is called data definition language. And that's what you use to tell the database how the table should look in the very first place. So this is saying things like define order, or orders, right? To set up a table of orders, you might define that table. Again, for us and our purposes here, that's all taken care of behind the scenes by Sails auto migrations. So let's start with DQL. What we're going to look at first is called a select query. So this is the most common thing you're going to see in the land of SQL. And the easiest way to write a select query, type select star from, and then the name of the table. So star means everything, and then from is just saying which table, and pet is the name of the table. So I'll run that query, and you can see I get a little mini table here of results.
Do you always have to write in all caps for queries?
I don't know. Probably depends on the database. These can be more efficient than using an ORM like Waterline, right? The problem is that, like, yeah, if you had unlimited time in the world, you could always do everything fully optimized from the beginning. You could write your entire backend in assembly language. And in the last 2 years, we've only used them once on one project. And we've done a lot of projects, right? Because it's just like not really that important to be able to optimize queries most of the time. Usually the problem is that you have too many queries, or that you're doing queries with too many things at once. Not that the queries themselves could be micro-optimized. I don't know whether it has to be capitalized or not. Apparently not with MySQL. So what you'll see though usually is it written like this. White space is kind of open-ended too. You usually want to end it, I think always want to end it in a semicolon. So you can also say what you're selecting specifically. So I'm doing select star. I could also just do select ID, because that's the name of one of my columns, right? And now I see just the IDs. Now sometimes, depending on which database you're using, or the names of your tables even, this won't work for you, right? You're gonna find some weird error in this case. And what you'll end up having to do is something like this: select pet.id. And it's trying to help me out by autocompleting. And the reason why that's the case is that sometimes these queries can get pretty involved, and you'll end up with multiple different things, different kinds of things. And so you have to clarify which ID am I talking about. Well, I mean the pet ID. So I would do pet.id. That's just the name of the table, followed by dot, followed by the name of the column. How would I look up just the pet names? Like Spot, Rex, Alice. Select name from pet. Now this is lighting up blue, which makes me nervous, but let's try running it anyway. Okay, it works. It just lit up blue.
So otherwise you could do pet.name?
Exactly. We could do pet.name. If I wanted to do the ID and the name of the pet, I could do pet.id, pet.name. And then I get the ID and the name. All right, so now I'm going to actually, for the sake of comparison, I'm going to generate a new Sails project. And we're going to compare how this works in the ORM. Well, while that's generating, let's charge on ahead. So we've looked at how you can select everything from a table, all the records, aka rows, right, from a table. We've talked about how you can select only certain columns while you select those records, but we haven't talked about filtering yet, and we haven't talked about sorting, and we haven't talked about pagination. So let's start with sorting. The way sorting works in SQL is order by. This is the same thing as sort in Waterline. So in our case, we might do like order by pet.name. So I would assume then in that case, the first thing we're going to see is Alice, right? And sure enough, Alice, Felix, Greywind, etc. Now, if I wanted it to be in reverse order and I want to see Tony last, followed by Spot, then Speedy, then I could do descending. Or if I wanted to be more explicit, I could put ascending. And when I do ascending, I get A through Z. Descending, I get Z through A. If those were numbers, descending would mean biggest number first, smallest number last, and vice versa. So that's how sorting works. Now the next thing we're going to want to talk about is pagination. And so that's where you've got like, right now we only have a handful of pets, right? But let's say that we had like 800,000 pets or so. That would be too many to show at one time, right, for our purposes. Whether you're in Tableau or like a BI tool doing a SQL query for that, or you're doing a native query to squeeze a little extra performance out of your application, although to anyone watching this, please don't ever do that unless it's actually necessary. But for whatever the reason you're writing these queries, you need to paginate sometimes. So the way that works is with these things called limit, well, not skip. In Waterline and Sails, we call it limit and skip. In SQL, it's called limit and offset. So first of all, right now we've got what, 1, 4, 8 things. So let's just get the first 5, right? So we'll do select pet ID pet name from pet limit 5 order by pet dot name descending. Let's change it to ascending, and this will give us the first 5 pets A through Z. Except that I typed it wrong. Okay, it just goes after the order by. You notice I didn't actually read this error message, and that's because unfortunately it's not always the most useful. Still worth a shot. Okay, so limit 5. Now let's say that we had a little button that said page 1 of 2, page 2 of 2, right? And you wanted to hit the next page option. Well, then this is great for giving you the first page, but the next page we need to use offset. So I believe it's limit 5, offset 5. Offset 5 says skip the first 5 and give me the next 5. If you were in the world of Sails, you could do something like pet.find.paginate. And for the first page, you would do 0, and that would give you a reasonable page size. Second page 1, third page 2, fourth page 3, and so forth. And you could also set the page size. So we wanted a page size of 5. That would be our first page, second page, third page, fourth page, and so forth. You could also do limit 5, skip. 0 for page 1, page 2, page 3, and so forth. So that thing really, when you're writing code like this in Sails, it just translates to stuff like this. Let's actually run this. And sure enough, we got lucky and I typed it correctly. So we only see 3 things, right? Even though our limit is 5. And that's because there's only 3 things after you skip 5 of them, because there's only 8 things total. Okay, last but not least, the most exciting clause of all here is the where clause. So let's say, and you can actually use where clause with all of this stuff. You can do sort, you can do limit, you can do skip, aka offset, right? You can do all this at the same time as you do a filter with where, but I'm going to delete it for simplicity. Okay, so here we go again, all the pets, all 8 pets. Now, if I want to do where name is, and I'll do pet.name for consistency here, is equal to spot, then I get just spot. If I would do where pet.name is equal to Drover, I get nothing because there's no pets named Drover. You can also do multiple things, right? So I could do where pet.name is equal to spot, and I could do or pet.name is equal to Drover. And you can see there's no pets named Drover, but there is a pet named Spot, so I got what I wanted. And so I could even get fancier with it. I could say where pet ID is equal to 1 and pet.name is equal to Spot, or pet.name is equal to Drover, and I'm using parentheses. So I'm saying pet ID has to be 1 and one of these has to be true. So you can use and or all mixed up, right? You can use, as long as you use parentheses to indicate the order of operations. Now there is a default order of operations that if you were getting a CS degree or like a computer engineering degree, they would make you grind on forever about like, how to do like the Boolean algebra of moving these things around. The fact of the matter is it's better to use parentheses anyway, so it's clear what's going on, right? In here, the parentheses are actually necessary. It turns out that and is like multiplication and or is like plus if you're working with them like in a mathy way, but who cares, right? Just use parentheses so that you actually understand what's going on and so that it's easier for other people reading the code. So I could say where, the pet ID has to be 1 and the pet name has to be Spot, or the pet name has to be Drover, or the pet name has to be Pete, and let's pick another column. well, let's say and pet.createdAt has to be greater than, let's say, like maybe yesterday. So that's the timestamp for today. If we want 24 hours from the current moment, then we might do like 1,000 times like 60. What is that? 60 seconds, 1 hour, 24 hours. Close enough. I don't even know if I did the math right, but I think it's probably correct. Close my parenthesis. So this pet spot was created at some time greater than this. If I change that to a less than, or no, that's actually not true. If I change that to a less than, it won't matter, because what this is saying is that either the pet's name is Spot or both of these are true. All right, we got greater than, we got less than. You'll find there's a lot of fun and exciting operators you can use here. Pretty much exactly the ones that you're going to see in the waterline documentation. There's more that you can do in SQL, and every database has its own little things that it lets you do. But at the end of the day, like what you actually need most of the time is equality, not equals, less than or equals, greater than or equals. And really, you don't even need greater than or equals and less than or equals, because you can always just adjust, right, and use greater than or less than. The other thing you'll see for strings, so these will check alphabetically for strings, but mainly they're designed for numbers, right? For strings, you'll also see contains, starts with, ends with, and in SQL, you don't actually see them written like this. You have to use kind of a special thing called like. So I'll get into that in just a second. But these are the kind of operators you're going to see most often. In SQL, there's also this thing, like specifically if you're checking equal to null. In SQL, the null is in all caps. Just, another one of those things. Hopefully, you guys won't have to check that very much, because you're going to be working with a database that is being, is integrated with the Sails application. So not a lot of our stuff is null, but every now and then it will be. So you don't do equal null, you do is null and is not null. So you would do like pet.name is not null, pet.name is null. The other thing to be aware of is this like thing. But let's start by simplifying our query a little bit, because we got a little crazy here. So let's get all of our pets at once again. We got Spot, we got Rex, Alice, and so forth. So let's find pets where pet.name is greater than Felix. So these are things that are alphabetically after Felix. And we'll go ahead and order by pet.name ascending, so we can see them in order. Now, if I wanted to be greater than or equal to Felix, then it's going to include Felix. But just greater than Felix excludes Felix. I could do the same kind of stuff by doing pet.id greater than like 5, let's say, right? So here are the ones that have a pet name greater than 5. And I'll even order by ID so we can see them in order. All right, so now let's do some stuff with strings. So let's say that I want to check for pets. Let's say I am not using an ORM, right, which I don't recommend again, but let's say that I was there just for the sake of example, and I was going to search for a pet, right? So I can do pet.name. So I could search for an exact match, right? I could say pet.name is equal to Tony, and that's going to give me Tony. But let's say that I want to find any pets whose name contains the letter T. So I can use like for that, because I couldn't use equal, right? That would just give me pets whose name is T. I want to do like a contained search. So I can do like T, and unfortunately like T isn't going to be enough. If I try to run that, I get nothing. Like is this special thing that you can kind of think as like a super operator for like every permutation of contains, starts with, ends with. So with like, if I want to do a search for things that contain the letter T, I put a % sign on both sides. And you can see I get Spot and Tony. If I want things that start with the letter T, then I get rid of the % sign on the left side of T. And if I want things that end with T, I get rid of the % sign on the right side of T. And then I get Spot. Basically, these % signs are like wildcards. I know you guys haven't looked at regexes very much, but when you see something like this, that's kind of like saying, if this was a JavaScript regular expression, That's a wild card. That's a wild card. That's the letter T. That's a wild card. That's a wild card. That's the letter T. Now that we've covered select queries, that's pretty much it. Now there's more you can do, which I'm going to come back to at the very end here of today. We're going to talk about something called joins. But that's select queries, and I want to move on into some basic DML, data manipulation language, next. Before you do that, one more thing you can do with select queries. Sometimes it can be useful to do some aggregation, some math, some averaging. The three most common types of things you're going to see are sum, average, and count. Count, and then we'll just pick one of the columns, right? You can also put star, it doesn't matter. But actually, generally, it's a good idea, especially if you don't feel super confident with SQL yet, to just say a specific column. Because that way, if you're doing a more complicated query, you won't get mixed up. There it is. Select count and then the name of the column from pet. But I can also select count with a filter on, right? So I can select count pet.id from pet where pet.id is greater than 4. That's going to be 4. I could do count how many pets there are named Spot with 1. I could count how many pets there are whose name has a T in it. 2. Right? Just like how before, and in fact, I could count that, and weirdly, I could include the ID and the name of the pet. Assuming that well, no, I couldn't. And it's this error message is actually pretty useful. It says, in aggregated query without group by, expression number 2 of select list contains non-aggregated column. This is incompatible with some yada yada. So what it's saying is that it would be weird, right? This would make every single result have the number of pets followed by that pet's ID, that pet's name. It's kind of weird, right? So you wouldn't actually want to do this. But that's how many pets there are that have T in their name. All right, so we talked about that. Now let's talk about sum. So sum is another one of these aggregators, right? Like it's like an aggregation. If you remember from math, when you would see stuff like this with the big M, and you have like the sigma, and you have like I equals 0 or whatever, not everyone got that particular math. Like I didn't ever get it super great, honestly, but like that's an aggregation function. And that's what we're doing here is we're aggregating. We're saying how many pets are there like this. So let's say that pets have PetSmart points, and that's going to be a number. That's fine. And I'm just going to, for consistency, make it the same. You'll see there's all these things you can select. We're not going to get into that right now. This is the table structure. And this is like because certain things, especially back in the day, it mattered more. Now it barely matters. But the best thing to do is if you're adding a column, make it match the other things like it. I know that in the Sails app this is associated with, this must be type number. And then I know that over here, this is also going to be type number, and I want it to match. So this is the number of PetSmart points each pet has. And right now, they all have null PetSmart points. Well, keep in mind, we want it to 0, the base value. All right, so now we have some well, let's say we give Graywing, your cat, some PetSmart points. We'll give your cat 500 PetSmart points. And actually, let's give Rory like 300 PetSmart points. Rory's my cat. All right. All right, so now we're going to sum their PetSmart points. And let's just get all of the PetSmart points that all of the pets have all together. 800, right? Okay. 500 plus 300. Let's sum up PetSmart points from pets that have a name that contains a R or contains a capital G. Now, my SQL is case insensitive by default, so it doesn't matter if I put a capital G. See, it's still 800 or a lowercase g. There's Graywing's 500. And you can see the G doesn't matter. That's going to vary depending on your database. And actually, for context, Sails and Waterline, they don't actually normalize this behavior. So if you have an app that you built on MySQL and you're relying on this case-insensitive behavior, and you switch to Postgres, which is not case-insensitive, then your code might behave differently. But that's a change that we made because it was causing. We used to not do it this way, and it was causing a lot of performance problems in the ORM, and it wasn't worth it basically. So we changed it so that it is completely up to your database adapter. All right, so we talked about sum. Now let's see average. Okay, the average happens to be 100. But what's the average number of PetSmart points across our pets? Well, it makes sense because 300 plus 500 is 800, and there's 8 pets. 800 divided by 8, 100, right? So let's see what the average PetSmart points are for Greywind and Rory. And I'm going to take this opportunity to show you guys one more thing that comes up a lot, okay? Which is where, well, I guess first let's do it the way we've talked about so far, where pet.name is equal to Rory, or pet.name is equal to Greywind's. The average is 400 because 500 plus 300 divided by 2, 400, right? And I'm just going to drive this home. So first of all, I'm just showing you I did average and sum at the same time now. Let's see if I try to change the sum one to be on name. It tries its best, you know?
Okay.
I wouldn't rely on that behavior ever. Right?
Yeah.
Okay, and so one other thing. So you guys see this query here. The next thing I'm going to do is show you something that I really should have covered earlier, probably when we were there with the modifiers, like greater than and the like and stuff.
Okay.
So let's look up Rory's ID and Greywind's ID. You see Rory is actually number 4 and Greywind is number 8. So if I were to do pet.id equals Rory was 4 and pet.id is equal to 8 because Greywind was 8, same deal, right? Another way to do this is to use what's called an inquiry. I don't know what it's properly called. I call it an inquiry, where you do where pet ID. And I'll actually take this opportunity to show you guys how to do a SQL comment as well. That's just commenting it out, that part.
Oh, okay.
You just do dash dash. So now I'm going to do, instead of where pet ID is equal to 4 or pet ID is equal to 8, now I'm going to do where pet.id is in 4 or 8. That's the same thing as saying pet ID equals 4 or pet ID equals 8. So I could do pet.name is in Rory, Greywind. So I actually kind of neglected our little example app that we created here. This is a little sales app. I'm going to generate a model called pet, and I'm going to generate, well, I'll just start like that. Open up our pet. Whoa. So our pet is going to have a name, which is going to be a string, and it's going to have, we always get ID created at and updated at by default. But our pet is also going to have PetSmart points, which is a number, oops, type number, right? All right, so pet.find, and I'm doing .log because I'm on the command line. Normally in your code, you would write await pet.find. By the time whoever's watching this video is watching it, this may be supported in the Node REPL. It might even be supported on some versions of Node 10, but it's not right now for me, so I'm going to use pet.log. You can see if you see something like this, it's because you need to use pet.find.log. Only in the REPL. The REPL is this thing I'm in right now. It stands for read, evaluate, print loop. But really it just means a way to talk to it. Okay, so we don't have any pets yet, so I'm going to do a pet.create. And I made a pet, and now when I find it, I can see my pet. It doesn't have a name, doesn't have any PetSmart points, okay? Cool, so now I want to do pet.find where, and in Sails, you can actually just put the where clause right there in line. That's how you'll usually see it written. So I'm going to find pets where ID is equal to 1. Oops, and I forgot to do a .log, so in about 15 seconds, it's going to get mad at me, so just be ready. But anyways, here I did it with log. And there it is, working. If I was to look up pets whose ID is 2, I get nothing. And there's the thing I was talking about. You can ignore that. That's because I didn't type .log for await. That's there to help me out in case I accidentally did that in my code. Okay, and the reason I'm showing you this is because pet.find, where ID is in 1, 2, 3. Does that look familiar? That's the same thing as writing selects from pet, let's do star, where pet.id is in 1, 2, 3. That's just, this is turning in to this behind the scenes. That's what Waterlion's doing through its adapter. All right. So that's about it for select queries right now. Next thing on our list is to cover inserts. And now with the caveat that you can basically look this up at any time, I'm just going to blow through it pretty quickly. So I'm going to do insert into pet, and then I'm going to say the columns, and let's just put the name of the column, which it might be pet.name. I don't know. So values, and then let's say, John, what's the name of your cat? Mimi. Doesn't like.
I think that's supposed to be, yeah.
Yep. And now Mimi has joined us. I'm going to fix her up.
Did you have to put Mimi in a string so it understood that it's a string?
Yes, with double quotes. 450 PetSmart points. So that's an insert, really. You can insert more than one thing at the same time. I'm not going to go into more of this right now because when you're writing native queries like this, or like when I say native queries, I mean SQL. When you're writing SQL, most of the time it's because you can't do whatever you're trying to do with the ORM, or because you're trying to squeeze out performance. So that's it for insert. Now, next, update. So insert creates a record. Update is going to modify a record. So let's just pull up our good friend W3 schools here. We do update, set, and then we can actually do a where if we want. If you don't put a where clause, you update literally everything. So let's say I wanted to capitalize Rory's name. Now what I would really do for this is just go in here and I could just change it, right? That'd be one way. Behind the scenes, SQL Pro, which is an application that someone wrote, right, or some people wrote, it's actually just doing a SQL query like this when I change. So you can see one row affected down here. I ran it. That's it nodding its head at us when we sent it this SQL. And now if I refresh over here, Rory has a capital R. You can destroy, if you don't put where, it's going to destroy all of them. Yeah, which is interesting default behavior, but that's where we ended up since 1970 or whatever.
Okay.
Which is part of the reason why we generate these things, right? Because we haven't even talked about like SQL escaping and stuff, because right now we're not going to get into that. But there's a lot, it can be kind of dangerous to write SQL if you don't know what you're doing, because you can mess up the database. With select queries, generally you're safe as long as you're not accepting any untrusted user data. So if you're building stuff in Tableau or whatever, or Grow for a business intelligence dashboard, like you don't need to worry about that because all of your data is like hard-coded. You're putting it in there yourself. Now, if you're using data from the database to do that select query, then you still got to be careful. Although hopefully you don't have anything in your database that has dangerous SQL in it. So in our case, for what we're talking about here, I think we're not going to go into it any further. Just know that if you're unsure whether it's going to be safe for you, and you're not completely sure that it's going to be safe for you to write SQL queries by hand, then you should use an ORM or learn more about SQL escaping. So the question was, is it possible to undo in tools like SQL Pro? And unfortunately, there's not the biggest incentive for new feature development in these things, like a lot of developer tools, because there's no way to get paid, right? Like we're just using SQL Pro for free. So no, and you can't undo it. Which is why if this is the production database, you've got to be real careful. And you'll see that I have my production databases flagged red so that I don't accidentally get confused and mess with them. All right, one other thing, we talked about the ORM, and I just want to introduce you to some concepts really quick. So you saw me earlier when I did like pet.find. That's getting converted into a select query if I'm using a SQL database. I might not be using a database that supports SQL, which is part of the reason why Waterline can work with something like Mongo or Sails.js, because those databases are not SQL databases. All of that is taken care of in something called the adapter. So Sails is a framework that has a lot of pluggable, hooks, right, which implement different features. One of those hooks is called the ORM hook, and that hook is what brings in Waterline, and then Waterline knows about what adapter you have installed and then in your project, and then Waterline will use that adapter to convert this to something that looks instead like that. All right, so last but not least, let's talk about joins. Okay, let's say that I also have another table called PetSmart location. So PetSmart location, it's got an ID, which happened automatically thanks to SQL Pro, which is cool. And let's say the PetSmart location actually has a little bit more. And so here's where I'm going to switch actually to a different database. I'm going to grab this database name, test4271. I'm going to go into my local project. I'm going to configure it to use a local data store. And I'm actually going to use this new adapter called Sails SQL. I'm going to use root at 127.0.0.1, which is my local database. And it's called test427.1, which is a weird name, but that's because I think it was for issue number 4271 or something. All right, and then I need to npm install Sails SQL. So anyways, while that's going, what that's going to do when I lift here in a second is it's actually going to wipe out everything we've done because it's going to auto-migrate because I'm running in development, and it's just going to crash all this stuff. And that's fine. We don't need this stuff anymore. So instead, I'm actually going to set this up with my models because it's faster. All right, so I have a pet model, has a name, PetSmart points. Let's say I want to go ahead and generate my PetSmart location model. Oops, forgot to type model. There we go. So you can see now I have a PetSmart location. And maybe my PetSmart location has a street address, which let's just call it address 1. And then maybe it has like address 2. Maybe it has like city, right? State, but let's use province because, oh man, when you start using the word state and status, you just get all mixed up. All right, so that's like a, everything except the zip code. We'll throw a zip code in there. Okay. So these are completely separate tables. I'm actually gonna go ahead and lift that server. We'll see what happens in here. Yeah, you can see it actually wiped all of our stuff, right? Well, it managed to keep our pets, so it tried its best. And there were enough overlapping things, PetSmart points and name, right? So the question is that what Sails did because of using the alter auto migration strategy? And the answer is yes, that is why. So Sails, when you use the alter auto migration strategy, it's just kind of like, well, I'm going to delete everything. I'm going to drop all the tables. I'm going to recreate all the tables because I don't care right now because I know this data is important. Obviously, in production, it doesn't do that. But in this case, it dropped them and recreated them. It managed to hold all of the contents in memory because there's only 9 and not 900,000. And then it was able to insert them back into the table. All right, so we got a pet. We got PetSmart locations. Let's go ahead and create one. We'll do like PetSmart location.create. We won't even put like the rest of the address right now. We'll just put like city, Austin, province, Texas. And remember, we're on the REPL, so we have to do .log. And there's the Austin location of PetSmart. So now we'll change our models actually, and we're going to associate a pet to a PetSmart location. So let's say that these pets are like at the PetSmart. These are pets who are currently inside the PetSmart. We have smart collars, and we're tracking all of the pets. It's a little bit creepy.
They're getting groomed.
They're getting groomed. There we go. Currently being groomed at PetSmart location. That's pretty long and nasty, but let's just run with it. And this isn't going to be a type because this is an association. So we're actually going to say model PetSmart location. And I missed a comma up here is why it's lighting up for me. That makes sense. This is a singular association, meaning that this pet, every pet could be currently being groomed at PetSmart location. And there could be 1 or 0 PetSmart locations where they are being groomed at currently, right now, right? Because a pet can only be in one PetSmart at a time. All right. So let's kill a server, start it again. Auto migrations are happening. We're going to see this new column. And this does have null, and that's on purpose because this is a special association column. Really, though, it's just a number. So pet.find is going to give us all our pets. Let's take Greywind into the groomers. So pet.find 8 is the same thing as writing pet.find ID is equal to 8. Okay. Whoa. Okay, this is an error message or warning message that I wrote, and you can tell it was me because it's really long. And it's saying, whoa, I found something that I'm uncomfortable with. Okay. It's saying a record in the result has a value with an unexpected data type for property updated at. It says it's a number, but instead of, it says it's supposed to be an auto timestamp, but instead of a valid timestamp, the actual value in the record is 0. Now you're seeing this because, which is a rare message, but really you don't ever want a timestamp to be 0, right? If it's one of these built-in timestamps, because chances are it wasn't created at or updated at on January 1st, 1970 in Greenwich, England at midnight. That's what 0 means. So that's called the Unix epoch, but that's a conversation for another time. But that's what these timestamps are, right? So anyway, 0 is like, you're never going to create or update these records at that time. It's possible for legacy data, and you know, people can feel free to roast me on the internet if they care, or they can contribute and help maybe improve that. But I think for now, it's actually pretty good default behavior, and it's worked really well for us. So ignore that warning for right now. Let's just go ahead and we'll change that while we're in here. Let's just, we'll have Greywind getting created and updated at the same time as everybody else. So now I'm actually going to run that query again, and no warnings, right? And those are just warnings anyway. So anyways, here's Greywind. You can see that Greywind is not currently being groomed at a PetSmart location. So I could go change that, actually, if I wanted right here. I could say that Greywind is going to be groomed at PetSmart location number 1. And let's have Mimi go in for grooming as well, and Rory. We're all going to get our cats groomed. All right, this will be a first-time experience. All right, so we're getting our cats groomed. They're all associated up now, and you can see that when I do that find, you can see currently being groomed at PetSmart location 1. All right, so here's the deal. If you're using Sails and Waterline, you can also do populate currently being groomed at PetSmart location, and that's going to populate. Now it's this nested dictionary. That is accomplishing a lot of what you accomplish with a join. Now, joins are a lot more flexible than this, and under the covers, when you're using a SQL database, this is using joins in Sails and Waterline. I just wanted to show you this first because it's a little bit easier to wrap your head around, okay? Joins are similar, and they serve a similar purpose. They're just a more flexible, lower level abstraction. They're a way to do all kinds of different munging and smunging and lunging of data. Okay, so you can take maybe like a bazillion different tables and like join them all together and like figure some stuff out, maybe group some things up. Maybe you need to figure out like what's the average. I want a table of all of the PetSmart locations with their ID and their name, and then I want a column on that table to have the number of pets who are currently at each PetSmart location. We're gonna do select star from pet to get started again. There's our pets, and I can also do select star from PetSmart location, right? And that's our PetSmart locations. So now let's do a little join. So we're gonna to do a join, and I'm gonna bust this out on multiple lines so it's easier to read. I'm not gonna show you inner join right now. I'm gonna do left outer join, and then I specify the name of another table, PetSmart location, on pet dot currently being groomed at PetSmart location equals PetSmart location dot ID. And let me shrink that down so that we can actually read that a little bit better. So what's going on here is that's our table, pet dot currently being groomed at PetSmart location. So I wanna join up this table right here with a different table with this table here, the PetSmart locations table, and I wanna combine them. But when you combine two tables like this, you've got to say like, okay, how do I know which rows go with which rows, right? And the way we're gonna know is this on thing. So we're saying this table and this column, the pet dot currently being groomed at PetSmart location, that column is going to be joined up with PetSmart location dot ID, which is the ID column of this table, the PetSmart locations. So let's just run it. All right, so now we have a bunch more stuff, and you can see why you end up wanting to be able to do like pet dot or PetSmart location dot, because now you've got two created ats, right? You got two updated ats, and you got two columns that are both called ID. It's kind of confusing, right? So let's make it a little bit easier. Instead of doing star, let's do select city. We'll do PetSmartLocation.city, PetSmartLocation.province, and then let's do like pet.name. So we can see Rory, Graywin, and Mimi are all getting groomed in Austin, Texas, but Spot, Rex, Alice, Felix, Tony, and Speedy are just covered in matted hair. Who knows where they are? Remember, the whole point of SQL is just to get the database to give you some data in a format, or tell the database to do something, right, and have it nod in response. Okay, so I'm going to do one other little thing. We talked about it earlier, maybe having it show us each PetSmart location, then how many pets are there at each location. So let's do that actually. Instead of starting with pet and then left out or joining the PetSmart location, let's start with PetSmart location and then join up all the other stuff. So we're going to do select star from PetSmart location to start. And now for each PetSmart location, let's have it include how many pets are currently being groomed at that location. For now, let's just stick with it.
Okay.
What it really means is that it has to do with when there's null things and understanding whether or not you can like merge records together on. So we can do pet.currently being groomed at PetSmart location, right? We want when that is equal to. So now, okay, here's my stuff. I got a whole bunch of stuff in here, right?
Yeah.
So let's do PetSmart location.city. What else? The province. Now I think we want the number of, so this is weird, right? We've got 3 rows, but what we really want is 1 row per PetSmart location. Let's try this. Let's try doing, okay. So that's what, it starts to get kind of more complicated. Also, I barely understand how to write any kind of code, much less SQL. So like, yeah, you're gonna have to like look it up and stuff because it slips your mind and it doesn't actually matter most of the time. But what this is doing is it's grouping up PetSmart locations, or all of the rows that are in our results by PetSmart location ID, and then it's counting the number of rows that matched. And then it's kind of like munging that result set. So you can think about it like when you get when these query results are coming back, it's sort of like it's taking, okay, select whatever from whatever, and then we're gonna join it like this, and then the group by is like done last, kind of. Now, in reality, that's not actually how it works. Like inside the database itself, it's recognizing that you're going to do a group by, and it's like doing all kinds of crazy stuff. It's like doing stuff in parallel. It's trying to like pull all the pieces together and make sure that it's like doing it in the most efficient way, because that's like a database's job. But that's not our job. We don't really care. We just want it to work, right? So that's how we got the result we wanted. I'm sorry, we don't have time to go into group by and stuff further than that right now. But know that that's where the going gets more complicated. But SQL is actually pretty simple. So an outer join could be like a right outer join or a left outer join. It has to do with like what side, whether like by left it means this is like left and this is like right. Okay. Does that make sense? It helps if you look at it like that. Left, right. And it has to do with how it merges the rows together. Okay. The difference is that you're either going to be doing like a left outer join, a right outer join, or an inner join. Left outer join is a good kind of default, honestly, because then it's going to give you the expected results. Not necessarily the expected results you want, but it's going to give you results that are closer to what you were expecting, I think, in most cases, at least in my experience. Okay, so to recap, today we covered the basic databases that are out there and the most common ones: MySQL, Postgres, SQL Server, aka MS SQL. And we briefly mentioned other stuff like MongoDB, although that's not a SQL database, so we didn't get into it. We also talked about how you physically run a SQL query, which in our case, we just used this app called SQL Pro. And then we looked at our local MySQL database, and we did a query on it using this query tab here. You can also use the command line, whatever you want, however frisky you want to get. We talked about DQL, DDL, and DML. Although mainly we just talked about DQL and a little bit about DML. Remember, those are just categories of different kinds of queries. We talked about select statements. We talked about how to use stuff other than select star to say which specific columns you want. We talked about how to use the where clause to filter the results you're getting. We talked about pagination with limit and offset, which in Sails and Waterline are going to be called limit and skip. We talked about sorting your data with order by, and we also talked about how to use sum and count and average aggregations. Then we talked about some basic DML, insert, update, delete. And then we did a really extremely basic intro to joins, mainly focused on left outer join just for simplicity. And that's pretty much it. And we touched on group by a little bit, but that's sort of out of the scope of this first lecture. So see you next time, I guess.